Hi, this is the Project Spark Alphabet. I'm Lady Lex UK, and today we're doing the letter G. And I've picked the generator with power cell and the game time tile. So let's start off with our prop, which is the assembly actually today. The generator with power cell. So you go into your assembly folder and go along to G. And you'll find so many enemies. Generator with power cell, there it is. Right, so you pop that down. As you can see, there's two objects here, what appears to be two objects. Let's pop them in the world. So you have this turbine generating thing and this power cell here. So let's see how it works. So you have like a hologrammy thing of a power cell next to this generator, and it's got a B comes up. If you press B, nothing happens. So you go and pick up this power cell. Now you'd have that hidden in your world somewhere, or maybe it's something that you get given on a quest. Come up to it, press B, and it slides in and turns your generator on. And once this power is on, you can use that to power up other things like doors, or maybe this you need to do this as part of your quest is to turn the energy on, whatever is necessary. And then if you press B again, it slides back out and goes back into your inventory. So pretty nifty little thing really. Let's see how it works. Okay, here is the power cell. It's got a very simple brain, interacted, it pick up me, and then when the player's got it in its inventory, then it will display a picture of itself, a screen top right. This second line, if you've got an inventory system and this interferes with it, just take this out. It's not going to stop this from working. It's just a visual display of the object to tell you that you've got it in your inventory. Okay, so that's that. Right, then you have the generator itself. There's nothing in that generator brain. It's completely empty. All of the code is found in this power cell, which is attached to our generator object, and it's just placed into this sort of open hole here. And in its brain it says when interacted, this person interacts with its inventory contains power cell. So if it's got the power cell, it's picked it up, then we'll power on and we'll pick up the power cell. So we'll remove it from the person's inventory and put it into the generator's inventory. When it has power, it will move with flying object down at speed 0.18. Now I know what you're thinking, I don't want it to move down, I want it to move across. But the power cell has been rotated 90 degrees, so now object down will actually move it left and right instead of up and down. So be careful with that when you're using movement, is that the orientation of the object will make a difference to which way it is going. It's to the object and not to the world. So object down, there's the other options there. Experiment with it to get it to go into the right direction, but that's what we're doing. Started to play sound, power cell insert, and then we're going to turn the power generator on, switch page to the next page, which is saying that the power is now on. Else we're going to play a hologram effect on our power cell to say put it here. And on our second page, after you've interacted with it, once you've got to this page, it's going to do the opposite. It's going to move with flying object up at speed 0.18. It's going to play the remove sound. It's going to let the player pick the power cell back off the generator, and then it's going to go back to being a hologram and turn off the power generator and turn the power off, and then go back to the first page so you can do it all again. So it's a straightforward little brain, this, and it's quite a nifty little bit of animation, and it's relatively simple to do. I've altered it slightly on this generator. As I pick that up and I slide it in. So you don't get a hologram effect this time. I've got a little drawer that goes in and out. There we go. I think that's slightly better. So let me show you how that's done. I've just attached the drawer to the power cell. and any attachments to anything is going to show up even though the visibility of this object is set to false. So what you do is you're on page 1, you set page entered visible equals false. Everything else is exactly the same except for when it has power, visible equals true. I've also changed the brain. Instead of turning on the generator with an in-world picker, I've chosen to turn on my owner. So whatever this is attached to, it will turn on. And that's very useful when you want to use this brain for lots of different props, especially if you're going to use one power cell and it's going to do multiple machines and doors and things like that. So use owner power on. And again on this page, this is all exactly the same. Owner power on. And that works just as well. So I've used an exact copy of this. I've just copied and pasted it. I just went like that. And then I attached it to my, over here, to that. That's what I did. I didn't change the brain yet. Okay, so I laid that next to my console here, and I took the brain of the console out, so there's no interact toggle on that if it's going to work with this power cell. And because I want it to slide in a different direction, I've got it so it's going to slide object forward this time and object backwards. Otherwise, exactly the same, because it's going to turn its owner's power on. So let's see. I'll put my power cell up, and just to prove I can use it in my generator, there it is. And I can also use it over here in my terminal. And as you can see, it's sliding side by side instead of in and out. And I've also got one in a door here. So I'll go up to the door and let's open the thing, and right, I need to, okay, I'll take it out, and the door closes. Right, so here we have a puzzle door, and it's a pretty simple puzzle door. I just put it in, open the door, quick, take it out, run in, and I can now use it on the second door. Okay, so how is this done? As you can see, this prop now uses a trigger zone. I've put a trigger zone in front of it so that you can only interact with this object when you're actually faced inside this box. And I've changed the code so when page is entered, door open equals false. This is just a boolean to tell me when the door is open. When page is entered, visible equals false, like it's same as before. And then I've added an extra line and made it this interact child line to it. In trigger zone, player. Everything else is the same. You go to page 2, again, in trigger zone, player. When you interact with it, all of it's the same. Now we get down here. Now we've changed this. I've set a duration timer to that move. I've moved it off of this line and I've moved it into its own line and given it a duration timer, so it's going to move the right amount of slide, and then we're going to change that boolean door open equals true, and then when door open equals true, we're going to do a countdown timer, and then we're going to turn the power off. Now this is a 1 second timer. You can have it quicker, faster, whatever you like, for a timed door. To give you time to, once you've taken it out, to run quickly through the door before the door shuts. 1 second is actually quite a lot of time for a player, so if you want to make it a bit more of a challenge, reduce that down. And there you go. So that's a timed door release. Other things can happen with the timer if you want to use this code with this boolean, but that's what I've done in this case. There we go. So there we have, and that's just, and that one in there is an exact copy of this, just attached to this door. Okay, so that was the power generator and how to get a nice sliding animation key for your game. Now let's have a look at our tile for today, which is the game time tile. And we're going to, I'm going to show you various ways that you can use it to create time effects. So here we go. I'm going to turn all the brains on because I turned them all off, so it was interfering with the tutorial. So here we have a selection of brains, and they're displaying time above them in slightly different ways. So the first one is representing this time just as the game time, and that's how it presents it, is lots and lots of fractions of time. It's a bit difficult to read, it flickers a bit, not really that suitable. This next one is showing the game time as just seconds, minutes and hours in a much more readable format, and that's a modifier. And this one is showing us game time as frames. So this is how many frames have already been played since I pressed that test button. And over here I've got a 24-hour clock. This is showing seconds as every second until it gets to 24 seconds, and then it goes back to 0 again. And this is how it's representing that, as if every second was an hour. So it's going through the hours of the day. And this one is going through the hours of the day, and then it's changing to the day of the week. So it's going through a weekly cycle as well. Okay, so let's have a look at the brains of those. Like I said, here is your basic one. Display game time above. Now the game time tile is found in World Properties. So you can find it in this tile, this segment here. There it is there. Game time. This next one, this is using the modifier as time. Now strangely, this as time modifier is not in the modifier section. It's loose. It is loose. There's no reason for it to be loose, but it is. It's loose on the wheel. So if you can't find it in the modifiers, that's where it's gone. But in frames, that's in the modifier segment, as you would expect it to be. Now then, the 24-hour clock. So what I've done is I said military time equals the game time, and I've used modulo, which is a really handy little tile, 24. So what this is doing is giving me a number after it's found its number that is remaining after you've taken away whatever number is after that modulo tile. So in this case it's 24. So if it was 1, it's going to show you a 1. If it was 25, it was going to show you a 1. If it was 49, it would show you a 1. If it was 26, it's going to show you a 2. So you see how this would work? So it goes round and round and round, going from 0 to 23 and then back to 0 again. So that's showing me my military time and giving me a 24-hour clock. And I'm just showing that as a time number above, as so. And then I've taken that military time, exactly the same, and I'm now going to display it as a 12-hour clock. So I need to establish whether it's morning or afternoon. So I say if the military time is less than or equal 11.99. Now the reason it's not 12 is because we don't want 12 to say AM. We want to say 12 noon. So we just do it up to 11.99 and say it equals AM. Otherwise it equals PM. Unless of course it's greater than 11.99 and less than 12.99, in which case it is noon. Now we're going to set another variable that is the same as our military time. We'll call it clock time. Clock time is the floor. We want a floor of this time because we don't want the full the full thing. We just want the last clock time. So that's going to round it down, basically. A bit like the timer as time. You can only use as time as a display. You can't use it to create create a number. Unfortunately, you can't do military time as time equals clock time for some reason. So we use the floor tile instead. The same thing. When clock time is greater than 12, clock time equals clock time minus 12. So we're just going to make sure it's a 12-hour clock instead of 24-hour clock. And if it's not equal to 0, we're going to display the clock time plus that text tile that says AM or PM. Else we're going to display 12 midnight, because that's our variable that we didn't put in. It's going to play 12 midnight, and that's what it's going to do. And that's that for the 24-hour clock. Now for the days of the week, we're going to set, now I've start my weekday equaling day 6. You can start that at day 1, whatever day you want it to start on. And then you've got a countdown timer that does the same thing, gets the military time. But every time the military time equals 0, we're going to increment our weekday. So once it gets to midnight, we're going to increment the weekday. And if the weekday is greater than 7, then our weekday equals 1. And we start again at day 1, which is a Monday. Weekday equals 1, day equals Monday. And we've got a text variable there to tell us what day of the week it is. And we've got the AM and PM is exactly the same as we had before. And now we're just displaying the clock time plus the day. And that's just a blank tile because I forgot to put a space in front of my day text variables. That just adds an extra little space in so they're all squished up together. Okay, that's it. So that's our 24-hour clock. Now then, what can you do with game time? It's all very well displaying this this time, but is it useful for anything? So here we have a pedestal. It says when game time equals 10, so when it gets 10 seconds of game time, go equals true. And when go equals true, for 3 seconds, it's going to play a torch flame above itself, and then go equals false. So it's going to do it once. So let's see that. Let's see that in action. So it's got 4, 5, 6, 7, 8, 9, 10 seconds. There we go. It's burning. 3 seconds. So it gets to, there we are. Done. That's very good if you want your items to run at a particular type of game at a different point in your game time. But let's say you wanted something to go in a loop. You could always set just an ordinary bog standard loop. You don't need a game time for this. But why not? Let's use it and see what it does. We'll use Modulo again. This time every 7 seconds. Every 7 seconds, go equals true. It's going to do a duration of 3. It's going to play that torch, and then it's going to stop. So this time it's going to, every time it gets to 7 seconds of game time, and it's got nothing to do with this brain. It's not got nothing to do with when I turn this brain on, and everything to do with game time, which is constant. It doesn't make any difference when I turn these brains on. It flames immediately. So I just happened to get it within a 7 second gap. So it should do it every 7 seconds. So 28. Boom. There we go. So anything that is a divided by 7, that's going to flame. There we go. Right then. Now this brain is a little bit, I've turned this brain completely off. So let's turn this brain on and see what this does. Right. Now we can see that the lights are going on off. The skyboxes are changing. And if I turn on our rest of our logic cubes here, you can see at 7 o'clock it goes dark. The night sky comes on, and at 6 o'clock the day one comes on. And if you look at our pedestal, when it becomes night time, so we get to 7 o'clock, here it is, it flames. So the torches are lit, and there's a flickering light there, and they turn off during the day. Now obviously I've got a very quick cycle here. I mean, it depends on how you run it. You can change your cycle very, very easily to I've done it for 1 second. You could make it so hours are every 10 seconds, or you could literally do it so a second is a second. I mean, you could have it running on real time. But whichever way you want to do it, however long you want your game time to be, and you wanted to create a nighttime daytime system, this is one of the ways you can do it using game time. And also let's have a look at the brain. So this time I'm saying game time modulo 24 is less than 6 or greater than 19, then global night equals true. Else global night equals false. When global night is true, go equals true. Your sky equals night clear. Sky equals day clear, else. Go equals false. On the else, when go is true, we're going to turn that torch flame on. And we're going to power on, else power off, and we've used a power connector between this pedestal and this light bulb, so the special effects turn on, and so does the light bulb to give us some light. And there you go. I hope that helps you out trying to make a system that will turn your days into days and nights on an automatic basis. And like I say, game time is totally independent on any other brain. It doesn't matter what brains are on or what brains are off. It is constant. As long as the brain that calculates your game time is on, it will run whatever you tell it to do. It will be totally independent of any other brains running, including world pace and everything else. You can't slow game time down. Game time is constant. Okay, thanks for watching. I hope that wasn't too long a tutorial for you. We'll be back next week, hopefully with the letter H. So thank you for watching and keep sparking.